All right. Today we're going to talk about section 7.2, dilations. First thing to remember is that dilations are a transformation that dilations. They preserve angle measures and they create similar figures. Okay. And dilation is really just a shrink or an enlargement. It'd be like taking a photograph and then enlarging it or shrinking it. All angles are preserved and we create similar figures. They look the same, just a smaller or larger version. So the first thing we're going to do is talk about a little bit of notation. So if I have a point, and we're just going to work with points here for a second. If I have a point XY, so let's call that point A, that's going to be the pre-image. It has an X coordinate and a Y coordinate. We'll just look at points. Like I said, a point for a minute. The image is going to be where that point moves to. And A prime, when we have a dilation, we are just going to multiply both the X coordinate and the Y coordinate by the same constant, the same number K, where K is called the scale factor. So if, for instance, I had a scale factor of 2, I would multiply both the X coordinate and the Y coordinate by the 2. In the first example that we do, we're going to have a scale factor of 3, so we would multiply both the X and the Y coordinate of point A by 3. Let's just get right into some examples here really quickly. So before we do that, we'll talk about the steps when you have the center at the origin. And we're only going to do dilations with center at the origin this year, I believe. So first thing we're going to do when we're performing a dilation is we're going to plot the pre-image point or points. Most of the time we will have more than one. And in the examples we do, we're going to do a dilation on a triangle and then on a quadrilateral. So we'll plot the important points, which will be the vertices, the corner points. So we'll plot the pre-image points and we'll connect them to create our triangle or quadrilateral, whatever we have. And then we're going to find the image points. So we will then find the image points. I'm not very happy with that. So let me start that again. Find the image point or points. Usually there will be more than one. And we do that by just multiplying by the scale factor. You will be given a scale factor. Remember, K is the scale factor. All right, K is the scale factor. So we're going to multiply by the scale factor, both the X and the Y, as it says up above. And then we're going to plot the image points. And after we've plotted the image points, we're going to connect them. And what we should see is a similar figure. So we'll plot the image points and we'll connect them. And if you need to write down the word connect to remind you to connect the points, then do that. Okay, so example 1. We're going to dilate the triangle that has vertices 1, 1, 4, 1, and 4, 4. So we have the point A, which is 1, 1. We have the point B, which is 4, 1. We have the point C, which is 4, 4. And under the dilation, look at what we have. So we're dilating with a scale factor of 3. So we're going to be multiplying by 3, because in this example, K is 3. That's the scale factor of 3. And the center is at the origin. So we literally just need to multiply the coordinates of A by 3, both the X and the Y. We're going to do the same thing on B. And we're going to do the same thing on C. So our A prime, the image of A, is going to be 3, 3, because 3 times 1 is 3. the image of B, 3 times 4 is 12. 3 times 1 is 3, so the image of B is going to be the point 12, 3. And then for C, we're going to do 4 times 3 and another 4 times 3, so the image of C, in other words, our C prime, is going to be 12, 12. Okay, so I'm going to plot my A, B, and C. So A is 1, 1, B is 4, 1. So here's A, here's B, and then finally C is 4, 4. So here's my original triangle. It's a little right triangle. Little right triangle ABC. And I'm going to dilate that. We've already got the coordinates of the image points, so we're going to just plot those. So A prime is going to be 3, 3. So there's A prime. B prime is going to be 12, 3. So we go out to 12 and up to 3. There's our B prime. Notice A prime, B prime is going to be horizontal, just like AB was. And then my C prime is 12, 12. It's going to be right up here. Notice my vertical BC is going to be transformed to a vertical B prime, C prime. So now that we have those coordinates, we're going to connect the dots. Notice the horizontal segment AB was transformed to a horizontal segment A prime, B prime that's 3 times as long. AB was 3, A prime, B prime is 9. From 3 to 12 is 9 units. And then finally, notice that the hypotenuse of my right triangle is parallel to the hypotenuse of my original right triangle. And that's true of the other legs as well. So when we do dilations, we take line segments to parallel line segments. In other words, we preserve angles. We're preserving angles. We're changing lengths, in this case, making them 3 times as long. But we are preserving angles and we're preserving shape, just not preserving size. Size changes. Okay, well, let's look at example 2. Another thing to notice is dilations can share a pre-image and image coordinates if the center is one of the pre-image coordinates. So in other words, if, we're only going to do dilations centered at the origin. So if I had the origin as one of the points of my triangle, anything times 0, 0 times another number is still 0. That point would not move. Okay. Let's go ahead and take a look at example 2. So we're going to dilate a quadrilateral this time. This quadrilateral is going to have vertices 6, 8, 4, -2, -6, +2, -6, 10. We're going to dilate by a scale factor of 1/2. So our K equals 1/2. So we're going to multiply by 1/2. We're centering it at the origin. And we're going to label the new vertices A prime, that prime almost got lost, B prime, C prime, and D prime. What are the coordinates of the new vertices? We'll list them here in a minute, but let's go ahead and draw the original quadrilateral. So we have 6, 8. Oh, we're off the graph. I need to go a little bit higher. So this is 7. 8's going to be right there. 9 is there. 10 is there. So we're going to go, because we need to go as high as 10, because point D goes up to 10. So we're going to go 6, 8, which is right here. There's our point A. Our point B is 4, -2. So here's point B. Point C is -6, +2. So there's point C. And then finally, point D is 6, 10. So it's going to be up straight above the point C that we have at 6, 10. All right, we're up here at 6, 10. So there's our point D. So notice that CD is a vertical segment. And when we do the dilation, it should transform to another vertical segment. The point DA, well, let's just connect them in order. So we'll go A to B to C, to D, and then back to A. All right. Oops, let me try that one again. That one didn't work super well. So I'm going to connect A over here to D over here. All right. If you have an index card, that makes a nice way of drawing, gives you a nice way of drawing nice straight lines. Okay, we're going to go ahead and we're going to list these points. A is 6, 8. We're going to multiply by a half. B is the point 4, negative 2. We're going to multiply by a half. C is the point negative 6, positive 2. We're going to multiply by a half. And finally, D is the point negative 6, 10. We're going to multiply both the x and the y coordinate by half. Because remember what we said up above in our notes, we multiply both the x coordinate and the y coordinate by our scale factor. So let me change colors. A prime, I'm going to multiply 6 by a half, we get 3. Multiplying by a half is the same as dividing by 2. Half of 8 is 4. And then for our B prime, half of 4, half of negative 2. For our C prime, half of negative 6, half of 2. For our D prime, half of negative 6, half of 10. And we'll go ahead and plot these points. So A prime is 3, 4, so we'll go out to 3, up to 4. So there's 3, 4. So there's A prime. B prime is going to be 2, negative 1. So there's our B prime. C prime is going to be negative 3, positive 1. So there's our C prime. And finally, D prime is negative 3, 5. So there's our D prime. We'll connect those dots. So we'll go A prime to B prime to C prime. Notice the parallels here. Notice the sides of my new quadrilateral are parallel to the sides of the old quadrilateral. In other words, the sides of the image are parallel to the sides of the pre-image. The slopes are the same. They're parallel. And also notice that the lengths of the images are half the lengths of the original sides. That is how a dilation works. So we have a similar quadrilateral because the angle sizes were preserved, angle measurements were preserved, but we have a smaller version. So we have similar figures, just a scaled down or smaller version. And that is dilation.